Okay. Hi everyone, welcome to the stream. So today I'm doing sort of like educational C++ live stream. My plan is to code something like a library that handles long numbers. It's more like a demo. It will be more like a demo that will demonstrate operator overloading in C++. And the whole point of doing this live is so you can ask questions and you can also ask unrelated or off-topic questions about C++ or programming in general, or live streaming. Yeah, OBS is getting really mature, and yeah, I actually like OBS a lot. It's really great. Yeah, I changed comics quite a lot. Hi, Abra. So I don't know. I actually like C++. I mean, it's not the best language in the world, in my opinion, and it certainly has its drawbacks. But I actually like a lot of core assumptions that C++ make. For example, you don't pay for what you don't use, or you pay only for what you use. And this sort of like low level. And C++ allows you to write both low level code and relatively high level code. And yeah, it's especially and it gets better because in C++ 11 things are much better now. Anyway, I actually still need to learn C++ 11, but okay. So I need to create a GitHub repo. Yeah, that was set in a comic. Yes, it's true. I mean, C++ has a lot of great things, and it also has drawbacks. And I'm pretty sure that C++ will be slowly replaced by newer languages, which to some extent happens right now. And it's kind of been attacked by languages like Rust, but at the same time, C++ isn't going anywhere. There are like millions or billions of lines of code in C++, and it's going to stay a popular language for quite some time. Okay, so let's create a repository named something like C++ demos. I don't know. I mean, I guess I will put it here, or maybe I will rename it later into something more meaningful. Let's add MIT. Wait a second. Okay, C++ is there. GitHub for C++. Let's add my MIT license. Let's create a repository. And okay, let's go. Basically, my C also definitely not going anywhere, but I'm not a fan of C because C is too low level for me. C++ has, and especially memory management. Memory management in C is horrible. In C++, we have nice things like smart pointers and whatnot. So C++ is much better for memory management. And it's relatively low overhead, in my opinion. I don't know, I never understood people who like C, because coding in C is like horrible. I mean, I can see that C is probably a good language for things like Linux kernel, but I don't know why would you code in C like desktop apps, for example. I mean, like manual memory management is just not very convenient. All these mallocs are free and frees are not convenient. And in C++, you don't have to do that. Okay, let's do this. Let's call it not long number CPP. What's the difference between C and C++? Well, there are quite a lot of differences. First of all, C and C++, C is sort of, C is kind of a subset of C++. So it's not an exact subset of C++, but it's close. So you can run almost any C program with little modification as C++ program. So C++ compilers typically can compile C programs. not all C programs, but like most of them. There are some differences, but C++ has quite a lot of backward compatibility with C. But at the same time, code written in C++ is very different from code written in C, because C++ has lots of interesting features, and the culture of these two languages is very different. So C's version of C++ not quite, more like, okay, so I'm going to show you. So a short history of C++. So there was a language called C, and there was a guy named Bjarne Stroustrup, and he was not quite happy with C. He wanted interesting features like object orientation and operator overloading and whatnot. So he started to develop a language called C++, and it actually wasn't called C++ for, I think, initially. Anyway, so he started developing a new language, and he based it on C, and so you can write C code in C++, but at the same time there are a lot of more interesting features. So that's true, pretty much this. C++ was developed as an extension of C, but it's right now it's much more than just a small extension. It's kind of like a huge extension. It's a separate language, and code written in these two languages tends to look very different. So yeah, but there is quite a why C2 classes, because it's an increment in C and in C++. So I guess it sort of makes in C or C++ you can write x++, and it increments the variable. So x is now 1. Have you tried Climb? Is it an IDE from JetBrains? I don't think I tried it. No, I just tried in Vim. I don't want to try it right now, and in fact I don't write much code, much C++ code nowadays. But I guess I could give it a shot. So why C2 classes? Okay, so this is called increment, and increments a variable, and so since C++ was sort of an extension of C and it didn't have a name, so it sort of became somehow people started calling it C++, which means something like the next C++ or like the next C or a better C. Yeah, I do remember it. It was that stream where about the button. Yeah, it was crazy. I streamed for almost 11 hours straight, and yeah, I was pretty tired. It was a great experience, though. Okay, let's go. So my goal for today is to code something like a small, tiny library for long numbers. And if you don't know what long numbers is, I'm going to show you this real quick. Let's say we have a number, I don't know, let's say 1 billion, right? So we need 9 zeros. Yes, so this is 1 billion. Again, y is 1 billion. Okay, let's see, say we want to print them. And my main goal is sort of to show you how to overload operators in C++. Okay, let's go. So let's say we have a new variable called y. So let's print, sorry, it's called z. Let's print z. And let's say we have a variable called a. And let's print a. So let's try this. Let's try typing. And okay, so we have two variables, each hold the value of 1 billion. So we add them together, we get 2 billions, and then we add z, x, and y again, and we get a negative number, which is, well, not mathematically correct. And the reason why is, well, because it overflows and and it becomes negative. It's sort of like the numbers are sort of like cycled. So after you go over a certain limit or the maximum positive number, you get into negative numbers. Not Tmux Lab. Actually, I think I need to launch Tmux. Let me. Yeah, it's a great idea. Are you going to implement and log-n multiplication? No, not today. I don't really want to implement and log-n multiplication. I actually don't know the algorithm. Okay, I forget. Okay, let's go. So what we need to do today is to try coding a better version of integers. So let's try doing this. Let's create our own class called, well, very long names. Oh, I don't know how to call it. I don't know. Let's call it integer, like Java calls sometimes. So big integer, yes, big integer. Yes, true. 5-second difference isn't big, I think, but if it worries you, I can adjust settings in OBS. Okay, let's go. We need a constructor. The most delay comes from RTMP, and some delay is pretty much unavoidable, but we tune the server so the delay is really low, something like 2 or 3 seconds typically. Okay, and let's call the constructor. So this class is going to hold a big integer. So how is going to be implemented? Okay, first of all, okay, let's go start with the internal implementation. So let's just use vector for holding digits, and we are going to store the numbers in base 10. So digits in base 10. It is not very space memory CPU efficient. What's it? Let's see to do. Basically, we are going to code something like a fairly naive implementation. I think that having a different base, so not base 10, but like, I don't know, but what's the best base for big integers? But I'm pretty sure that base 100 would work better. And again, this is not going to be super efficient right now, but let's start by implementing something. Are you sure? I mean, I don't know. How do people handle overflows in base 2? I'm actually wondering. I think it should be a fairly low-level code. I never wrote something like that. Vector bool definitely has some interesting optimizations. They basically store each bool as a bit. No, I don't think Putin is interested in me. Luckily, Putin isn't interested in me. Okay, let's go. So we have and we're going to store them as little Indian-ish, I guess. Okay. So where do we start? Yeah, let's try to write a constructor. So we are going to initialize a number by default with just 0, and yeah, does this work? What the hell? Oh, I made a typo. Okay, something is wrong with my Vim. Great. So again, let's start by implementing an increment. So the class is going to act as normal integers. So we need to do things like that. So we need to we want to do things like that. We want to instantiate an integer, and we want to basically do stuff like that. X plus plus, x plus y. So yeah, this is a kitchen. This is a kitchen. There is not a there is microwave oven, but not a yeah, it's a kitchen. Okay, so we want to do things like that, and the good thing about C++ is that it allows you to write your own implementation of plus or plus plus using operator. So actually, I mean, normally it's fairly useful for things like, well, big integers or for big integers, sometimes smart pointers. I don't think I use that a lot in my day-to-day code, but sometimes it's fairly useful. It's not that operator overloading is it's not like you should always use operator overloading, but sometimes it's like a very natural thing, like in for our big integer class. So let me quickly check how to overload plus plus. Actually, I think I remember that, but I'm just going to try, because there are two different plus pluses, and one of them takes one like a fake argument, and I don't remember which one. I think that's pre-increment is no argument function, but let me check this. Yes. You can manage. Okay, let's start implementing this. Okay, let's pass this. Actual increment takes place here. So this is how plus plus works. This is actually plus plus x. This is yes, obviously it should return big integer. So operators are kind of like specially named functions, and I think I think I remember reading about Lizard Squad, and someone got caught, and someone got so I don't know. Haskell I heard that operator overloading in Haskell is really cool, because you can overload pretty much every combination of characters. I think well, not every characters, but I think people do overload things like operators like this in Haskell. Okay. And again, this will compile, but this will not work. And again, we can see that it's not working. So increment code goes here. So right now, operator plus plus does nothing, and in fact, we can write pretty much any implementation. So instead of incrementing, we could instead double our number. That's not a good idea. So you please don't do that. Don't actually do this because it will be very surprising for people who will use the code. I know. I think that the DOS did for only a couple of hours. So I know. Actually, there was time in my life where I thought I understood monads. Okay. Let's write no. Let's write code that prints the number. So I'm wondering if there is a nice template for operator. Yes. Yes. Let's take this and actually it looks pretty cool. Okay. So so we want to do something like that, and to accomplish this, we need to overload operator left a bit shift left. So actually we can do it here, and we need to overload it as a. Am I right? Wait a second. Yes, we overloaded this as an external function. Actually, what's the proper term? Sometimes when I try to explain C++ concepts, I forget the proper terms in English. So, yeah, thank you for trolling me about my Vim use. So we iterate over digits, and we just print every digit. Actually, since we are storing the numbers in little endian-ish fashion, we need to iterate from size down to 0. Oh wait, yes. Wait a second. No. Yes. We have put them like that. So we simply output each digit, and yeah, done. So we need to make this function friend. I don't actually remember myself using friend function in day-to-day code, but it's really easy. So to make this function, to help this function access private fields of BigInt class, we need to declare it as friend, so it gets all the access to this field. Okay, let's try testing this code. And oh, we forgot to return the string. Actually, wait a second. It shouldn't be stdc out. Of course, it should be out. Write unit test. I never write unit tests. But in this case, unit test would be awesome. Okay, so we have to. What the hell? Did I wrote it twice? Wait a second. Of course, it should start here, and of course there shouldn't be any That's the handle, made a mistake. Okay, so it works. Right now we can write increment and print it again, right? Okay, but it doesn't work. So we incremented the number and it's not working. Why? Because we haven't wrote any actual increment code. So let's try this. Again, we need to handle carry overflow here, but this is going to look better. So as you can see, the increment sort of works, right? It keeps incrementing it, and actually I'm pretty sure that at some point it's going to overflow and it will not end well, but we will not see this. Okay, so overflow happens. We need to, when the digit reaches 10, we need to, what's the proper term? Well, I should have checked this before the stream, but like the digit, but overflow happens and we need to handle carry here. So let's do this. Let's iterate. Actually, it should be pretty simple. So okay, I don't know how to tell this code. We don't have operator equals. So we need to do write operator equals or equals equals. I don't know. Okay, so when the digit overflows, we just need to what we do is we check the size of the number. Implement plus and plus plus is plus 1 then. Well, that's true, but well, it doesn't actually. Well, we don't even this is not quite true because plus actually returns a new number. So we need to implement not plus but plus equals. So actually plus plus should be implemented using plus equals, not plus. I mean, it could be implemented using plus, but well, I think it's better to implement using plus equals. Okay. So what we do here, anyway, that's how I write code. I write code step by step, and I'm pretty sure that I could refactor this code into something more meaningful and readable within a few minutes. So let's just start by checking its size, more. Alright, actually, I don't know, should I use camel here? Okay, let's use camel here. Camel case. Okay, so let's handle carry. So to do this, we iterate over the. So carry happens when we have a number like that. We increment it. So we need to change this number to 0 and add 1 to the next digit, and so on, and so on, and well, so on, and we get 10,000. Okay, So we iterate over the numbers, and what we do is so we do simply this. Yes, it's actually like the bottom stream. You guys can bring back those memories. So we have carry and wait a second. It's yeah. Actually, I'm wondering if this is an operator in C++. I don't know. Actually, I'm actually not sure if this is a thing, but apparently it is. So we handle carry, and we need to handle buffer. I mean, we need to handle sort of size overflow here. So if we equals to digit size -1 and carry isn't equal to 0, we create a new digit. I think that should do that trick. I actually want to write a unit test. So yeah. Okay. No, I don't think it worked. I think it didn't really work because it's now 20. I'm actually wondering why. Now let's add some debug output. Oh, wait a second. Of course, we just resize the number only when it's necessary. Okay. So this still works, and hopefully, I don't know, should I? I mean, to write unit test, you need equality, and well, we don't have equality right now. We need to overload operator equals for quality testing. So I don't really want to. I don't want to write unit tests right now. Okay, so we have an increment that works fine. Okay, find me a library. Find me a good library for unit tests. So go and do it now. Find me a good library for unit testing in C++. Let me know what library to use, and I will start using it. When I worked at Yandex, we had an internal unit test library. So I have some experience using it, but outside of Yandex, I never really used unit test in C++. Okay, handle carry, we have this, and we can now implement plus operator. So I looked for one, then I gave up and just wrote the function expect equal myself, and that's enough testing for me. Um, okay, so we have a big integer result, and send related army here. I wanted to see it. I'm wondering what was actually what was the resize? Was it resize? I'm pretty sure it was resize, but let me check real quick. Yes, it's resize. We need to take. So we have our. So let's write plus. Implementing plus is actually fairly simple, since we have two numbers. Each has a certain amount of digits, and its result is going to have either maximum of digits or maximum of digits plus one. So yeah. So then number of digits in the result is maximum of this, and this digit size and other digit size. So we do this, and then we write a really simple loop. What the hell? Is it std max? Yes. No, of course we need to. I'm writing too much Python. Of course, there should be an arrow syntax. That's a really nice implementation of plus, I guess. So let's just iterate over. Actually, I think there could be some niceness. Okay, alright, yes. Digit size. And what really sucks is that what really sucks is that both of these. Okay, what really sucks is that we can't write this code, right? We can't write this digits I plus or digits I, because if those numbers have different amount of digits, this will lead to out of boundary error. So I'm going to write a simple helper function called getDigit. Actually, let's not use size div. Now let's just throw an exception. Let's throw an exception here. Is this a Hitler? So, and again, if index is more than digits size -1, we are going to return, actually, we are going to return 0. So in case if index is more than is out of boundary, we return 0 because this is a leading 0 essentially. Otherwise, we return digits idx. So now we can write almost a code that looks almost like this. So get digit I, other get digit I. And again, what we do here is essentially this. We have two numbers. Actually, say, right, and we add them. And I don't know, but I'm pretty sure that in your school, you added numbers like me. So what you did is this: you add these numbers, you get 3. Then you go here, you add these numbers, you get 11. But, well, you write 1 and you carry 1 to the next digit, so you get this. And this is the code that we are writing right now. This is essentially the same thing. And of course, you need to write const because it doesn't change the number itself. Add the numbers of stream. Yes, why not? Okay, but here we don't really handle carry. Luckily, we have a function for this. So what we do is we call handle carry function on, of course, this. I am a bit worried that's only 40%. Okay, let's add more. Reference to stack. What the hell? Yes, this returns a new. So operator plus takes another integer and it adds 2 integers and it returns a new instance. Hopefully, compiler will use named return optimization. So let's see. So we have x. Yeah, this part of it is a mess. Okay. That's it. And it works. And it actually does. I'm surprised. It's and it actually does. Let me check this real quick. Oops. I actually should write unit tests. So I have this feeling that instead of doing this, I should write unit tests. So let's write a bunch of ugly code for just testing because I'm too lazy. Yes, I mean, mostly I got annoyed by writing the code that looks like this. Anyway, the addition works. I guess, hopefully. Okay, so we had addition. We don't have subtraction, but who needs subtraction anyway? Let's write other stuff. So right now we can't write like things like that. So let's say we have z, and we can't write things like that, z plus v. Or can we? Maybe we can actually. I think we probably, yeah, it's auto-generated. That's actually grow good. We have operator. We have an assignment operator generated by the compiler, which is great, and it's actually correct because we don't do any non-trivial stuff. This is great. I don't know how to write FFT, like no idea. I'm a noob in Fourier transform, so don't expect this from me. All right, so this actually works. This is great. We don't need to write. Yeah, it works. Oh yeah, let's see if this works. This should, yes, it does. Again, as you can see, this also works. So, and as you can see, it's pretty neat. I mean, we have operator plus, we have operator that prints everything. That's done. Okay. I guess the next thing is testing for equality. So let's write an operator equals that will test for equality. So the first thing that needs, what's wrong? Let's just again, it's fairly easy to overload most of the C++ operators. You just do this. Turn false, and again. So how do we test two integers for equality? First, we compare sizes, and if sizes are different, then it's clearly two different numbers because, and if they are not different, okay, if you want, you can watch a recording later. So, and if sizes are actually equal, we just iterate over the digits. And we just test those digits for equality. Again, we just return false. Actually, I hate those braces. Let's remove them. Yeah. Alright. I think this looks neater. Where is the increment? What the hell? Okay. Don't do anything on stream. What do you mean? And otherwise they are equal. So we can now write code like that. We take, yeah, as you can see, now let's add some sort of padding here. Let's add some line separators here. As you can see, z equals to z, but z isn't equals to x, which is expected. All right, what do we need now? Okay, bye. See you again. Let's actually write a constructor that takes an integer and it actually doesn't work for, well, integers. So let's take one signed integer, and it creates a big integer from that. So yeah. Okay, it's no good. Again, let's write the constructor. We just iterate. Let's write a do while loop. So we take the current digit from the number, we push it back, and we divide x by 10. And, well, oops. Yeah. So what we can get here, so now we have a nice constructor that hopefully works. Let's test it actually. Um, 42. X plus y. And it works, as you can see, 185. That's nice. Okay. Okay, what do we need now? The problem with this syntax is that it actually calls a constructor. It doesn't call assignment operator, and actually assignment operator will not work. So for example, we can write big integer x equals to was 42 like here, but we can't write big integer y. We can't write code like that, or can we? I would be surprised. How does this even work? Oh, wait a second. Can we? That's actually neat. So sometimes C++ surprises me. Yeah, we can. And actually, initially I thought that we can't write code like that because we don't have an assignment operator that accepts normal integer as its second argument. But what I realized is that we have a constructor that accepts a normal assigned integer. So what actually happens here is, I guess, 82 gets converted into big integer, and then auto-generated assignment operator is called. Let me check this hypothesis. Yes, it gets called twice. That's surprising. I don't know. I never really expect this to work, but apparently C++ is a very nice thing. Again, by the way, if you have questions, totally let me know that. Okay, originally we wrote code that looked like this, right? So we have something like this. That is that z is equals to x plus y, and then we had a, it was equals to and it looked like, actually if I remember correctly, it looked like that: x, y, and o, right? Let's and at this point overflow happened with normal integers. Let's see if it happens with our big integers. Hopefully not, but well, we can be sure. And as you can see, it actually works. It's 5 billion. It's more than a normal integer can hold. So yeah, so it works. Again, this is the very beginning. I plan to continue working on this class, and I will do a couple more streams until this becomes a more complete prototype of big integer class. So let me commit this code. Start working on the class prototype. Okay, let's go. If you're interested in reading my code, it's available on my GitHub on C++ demos. I hope which worked. I don't know though. Okay, so yeah, I plan to continue those streams, and I will add things like unit test. I will add multiplication. I will add post increment and negative numbers, because it can handle negative numbers. But I hope you get an idea of how nice C++ overloaded operators are. Thank you very much for watching. The recording will be available on YouTube, and bye. Like I mentioned, I will do several more streams, probably this week.